4.2.3 is talking about compound interest. And the reason that this follows in line with this lesson is because compound interest is just an exponential function with a few different letters and other things thrown in there. So if you kind of look down to this formula within the box, you have a P, which is your starting value. You have a growth factor in parentheses, and it just includes an R and an N, and then you have an exponent, which includes an N as well as a T. But really, to boil it down, this is an exponential function. So if you're not familiar with interest, we're going to talk about the positive type of interest here. Interest, very simply, is the money that a bank gives you as a thank you for you giving them your money. So, for example, if you put $1,000 into a savings account, a bank is going to use that $1,000 to earn money for themselves, and then they kick you back a little bit of extra money as a thank you. So that's the good interest that we're talking about. Interest can be paid in two ways. It can be simple or it can be compound. Compound is the one we're going to focus on because it's exponential. But the idea of simple interest is that you only get the interest on the initial amount. So if you put $1,000 into the bank and they agree to pay you 10% interest, that's going to be $100 in interest. So you're going to have your 1,000 and you're going to add $100 the first year, add $100 the second year, add $100 the third year, and so on and so on. And you're only adding $100 because that is 10% of your original. With compound interest, you start earning on top of that interest and your new balance for the year. So it like builds on itself and it's exponential. So as you can see the formula here, P represents the principal. That's just a word that means starting amount. R is your rate, but we're going to make sure we use a decimal. N is the number of times that you're doing that in a year, the compounding, meaning that it's building on itself. And then T is always measured in years. So the formula is what it is. We're just going to plug in numbers and use it and just try to get familiar with it. So for A and B here, we are using the same $5,000 and the same 6% annual interest and the same 25 years. The only difference here is that our N value is changing between quarterly compounding and monthly compounding. So $5,000, that's your P value, that's your starting amount. 6%, we're going to use R is 0.06. We're converting 6% to a decimal. 25 years is our T value, and so the only thing that's left is our N value. Compounding quarterly, when you think about N, you think about the number of times in a year. So quarterly means you do something in the first quarter, the second quarter, the third quarter, and the fourth quarter. So your N is then going to be 4. So we're going to use the formula, and this is where Desmos makes it pretty easy. So we're going to do 5,000. The reason we're doing 1 plus, remember that if this is earning or growing, our growth factor needs to be bigger than 1. So it's going to be 1 represents all of your $5,000, and then we're tacking on 0.06 divided by that N value of 4. And then we're raising that to an exponent of our N value of 4 times our 25. Now, if it were me, I'm just going to type this in exactly how it is in Desmos. I understand that 4 times 25 is 100, so maybe you want to make your exponent 100. But if you leave it like this, it's really easy to go back into Desmos and just backspace the 4 and replace it with something else. Or if maybe we're like, oh, we don't want to know 25 years, now we want to know 15 years, all you have to do is backspace the 2 and the 25 and make it a 15. So I would keep this just like you have here and put it right into Desmos. And really, we're just trying to figure out how much money we're making. So if you type this all into Desmos, as I'm doing now, we figure out what our growth factor is, which is going to be bigger than 1. We're going to raise that to the 4 times 25, which, yes, we know is 100. And then we're multiplying this out. So after 25 years, we're going to earn ourselves, that $5,000 is going to turn into $22,160.23. That's, of course, if you don't touch it and you just let the money sit and earn and earn and earn. So then in the other case, we're using all the same P, R, and T value, but instead we're talking monthly. The number of times you're doing something in a year, if you do it monthly, once a month, you're going to do it 12 times. So the nice thing about what you guys have set up is if you're using Desmos, as you should be, you have everything set up for you. You're just going to backspace the first 4 and make it a 12. And you're going to backspace that second 4 and make it a 25. I highly suggest making sure you put your exponent in the parentheses when you have 2 numbers up there. So 12 times 25 and making that into parentheses. So I am working on a calculator here. So I just have to do a couple additional calculations. We're raising this to the 12 times 25. And then we are multiplying by 5,000. So with a few more compounding times during the year, instead of 4, it's now 12. We earn a little bit more money. So we got 22,324 and 85 cents. So when you build your interest on top of itself more times in a year, you're going to earn a little bit more money. But for you guys, 25 years, if you put in $5,000 and you got this interest rate, I'd be fine walking away with 22 grand.